Hello students, welcome back to my channel once again. So today we will be discussing the CBSE board grade 10. The chapter is surface areas and volumes. So this is going to be the part 3 video. I've already explained the previous part like surface area and volume. There are two already videos that are uploaded. So if you haven't watched yet, first watch it, then come back to this video. So let us see what we are going to learn in this video. So first we are going to cover the hemisphere. So earlier we have discussed about the cylinder, cone and sphere. So now we are going to discuss about the hemisphere. So let us understand what do you mean by hemisphere. So hemi means half. Okay, so basically hemisphere is nothing but the half of the sphere. So I think sphere you already know like a shape that looks like a football, right? So that is a shape of the sphere. So hemisphere means half of the sphere. So now let us consider some examples of hemisphere. So if you take this lemon, so whenever we cut this lemon into two halves, so one half is called the hemisphere. Now, if we take the bowl, so it looks like a, because if you join the two bowls together, it makes a sphere. So, a bowl looks like a hemisphere. Let us see the geometrical figure of the hemisphere. So, this is the geometrical figure. A hemisphere has two faces. So, one is the circular face, the top one, or if we just place it in the bottommost, then we can say the base one. So orange is the circular face and another one is the curved face. So this is the curved face. So there are two faces. Now let us consider the radius as r. Then the curved surface area of hemisphere will be. Now let us calculate the curved surface area. So we know that hemisphere is basically the half of sphere. So we already know the curved surface area of sphere. So in this case for hemisphere, the CSA, that is curved surface area, will be the curved surface area of sphere divided by 2, since it is half of the sphere. So we already know the CSA of sphere, that is 4 pi r square. So for hemisphere it will be 4 pi r square by 2, that becomes 2 pi r square. So that is the CSA of the hemisphere. Okay. Now coming to the total surface area of hemisphere, that is the TSA. So TSA here will be the curved surface area plus the circular face. Okay, so the curved surface area we know already that is 2 pi r square. This is the curved surface area. Now area of the circular face will be pi r square, because we know that the circular area of any circle is pi r square. So 2 pi r square plus r is r square. So that is 3 pi r square. So this is the total surface area or TSA of hemisphere. Now let us find the volume of hemisphere. So the volume is the capacity of the hemisphere, means how much it can contain, right? So the volume of hemisphere will be half of the volume of the sphere. Okay. So what is the volume of sphere? So half of the sphere. So first we need to know the volume of the sphere, that is 4 by 3 per r cube. Okay. So now if we cut, this is 2 by 3 per r cube. So that is the volume of the hemisphere. Now let us solve some problem based on hemisphere. So the first question is, the curved surface area of a hemisphere is 905 1 by 7 centimeter square. What is its volume? Okay. So here the curved surface area, that is CSA, is given. We need to find the volume of it. So CSA of hemisphere is given as 905 1 by 7 centimeter square. So if we just make it improper fraction, so 905 into 7 plus 1 by 7. So that is coming 6336 by 7 centimeter square. Now we need to find the volume. So what is the formula for finding the volume of the hemisphere? That is 2 by 3 pi r cube. So here only unknown term is r. So we need to find the r value here, right? So we can easily find the r from the CSA because we know the formula for finding the CSA of the hemisphere, that is 2 pi r square. So 2 pi r square is equal to, now that is going to be 6336 by 7. So let us equate this. Okay, now replace the pi value as 22 by 7 into pi r square. Now let us calculate it. So if we put everything in one side, then r square will become, now this we can easily cut this. So r square is becoming 144. So that is basically 12 square. So r will be 12 centimeter. So since we now know the value of r, now we can easily find the volume. Okay, so the volume will be 2 by 3 per r cube. So 2 by 3 into pi into r cube. Let's take the value. Okay, now cut this. So we are getting, now do the division. So I think this is self-explanatory. I don't need to explain how we are doing the division. Okay, it is coming around 3620.57 centimeter cube. So this is the approximate value because it keeps on going. So this is the volume of the hemisphere. Now we will take a look at the different problems based on the cylinder as well as the hemisphere. So the question is, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. Okay, so let us first understand the question. From there we need to draw the diagram. So what is given? A vessel is in the form of hollow hemisphere. Hollow means which is the inner portion is blank. Okay, so we call it empty. Hollow hemisphere. So mounted by a hollow cylinder. So that means there in the bottom there will be a hemisphere. On top of it there is a hollow cylinder. So hollow means that is also empty. The diameter of the hemisphere is 14 centimeters. So diameter is given. So the diameter is 14 means the radius will be 7 centimeter. And the total height of the vessel is given as 13 centimeters. So this is the total height. Find the inner surface area of the vessel. So we need to find the inner surface area. So inner surface area, the vessel is made up here. What is given? That the vessel is made up of cylinder and a hemisphere, right? So we need to find the inner surface area of the vessel. So now here inner surface area of the vessel is basically what? That is the CSA, that is the curved surface area of the cylinder, which one is highlighted now, and the curved surface area of the hemisphere. Okay, so that is the only the inner part. So now what we need to find? We need to find the CSA of the cylinder as well as the CSA of the hemisphere. So what is the formula for curved surface area of the cylinder? That is 2 pi RH. Okay, now what is the formula to find the curved surface area of the hemisphere? That is equal to 2 pi r square. Right. Now here one thing, r we know because r is the diameter is given, but h we need to find out. Okay, so because the total height is given, not h. Okay, because h will be the height of the cylindrical part, not the entire height. So here diameter is 14 centimeter. So radius will be diameter by 2, that is 7 centimeter. Okay, now this one we got that for cylinder as well as the hemisphere, the diameter, the radius is 7 centimeter. So R we already got. Now let us find the height of the cylinder. So if you take a look in the hemisphere, the radius and height is same. So that I have shown with the help of the diagram. So hemisphere, the height and the radius is same. So that is 7 centimeter. So the rest will be the height of the cylinder. Okay. So that is 13 minus 7. So height of the cylinder will be the height of the entire vessel minus the height of the hemisphere. So that is equal to 13 minus 7. Okay. So that is equal to 6 centimeter. So we already find out the age. So now we can calculate it is easily the CSA of cylinder as well the CSA of the hemisphere. So now let us first find the CSA of cylinder, that is equal to 2 pi RH. So 2 into pi into now R is 7 and H is 6 centimeter. So now let us replace the values of okay, let us for now let us keep it as it is. So it will be 84 pi centimeter square. Now let's find the CSA of hemisphere. So 2 pi r square, 2 into pi into 7 into 7. So it is coming 98 pi r centimeter square. So now if we combine this together, we will get the inner surface area of the vessel. So that is equal to 84 pi plus 98 pi. Okay. So that is coming 182 pi. Now replace the pi value as 22 by 7. So 26 into 22, it is coming 572 centimeters square. So this is the inner surface area of the vessel. So this is the final answer. Now let us solve a problem which is based on cone and hemisphere. So let us take a look at the problem. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. So you can now you can clearly see that in the previous videos we have only solved with the one hemisphere or one sphere or one cone. Now here will be in there, this is a combined figure like where there will be hemisphere with cone or hemisphere with cylinder. So that kind of problems will be there. Okay. So okay, let us again take back a look at the question. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. Okay, so let us first draw the diagram. So from the figure, what is given? A toy is in the form of a cone. So let us draw the cone which is mounted on a hemisphere. So mounted on a hemisphere means this is on top of the hemisphere. Okay, so mounted on a hemisphere means that is on top of the hemisphere. So both have the same radius. Now the total height of the toy is given 15.5. So it is a similar type of problem with the previous one. Earlier there was cylinder and now in this case we have a cone. That's the only difference. So now we need to find the total surface area of the toy. So total surface area means the entire toy that is made up of the cone and the hemisphere. Okay, so now first, what is the total surface area? That is, if you take a look, the total surface area will be the, we need to, since here, the base portion of the cone, okay, the circular one, that is not needed because that is internal. So TSM is the total surface area means the outside part. Okay, so outside part is the curved surface area of the cone and the curved surface area of the hemisphere, because we did not to consider the base over here because base is inside and that is not visible. Okay, so surface area whatever we have to consider, that is the CSA of the cone and the CSA of the hemisphere. So now what is the formula for finding the curved surface area of cone? So that is pi r l. So here what is given, that we will take a look. Here's radius is given and the total height is given. And we also need to know the formula for finding the curved surface area of the hemisphere. So that is 2 pi r square. So here r value we know, but we don't know L. But we know that L is nothing but square root of h square plus r square. So if we can find the h, that height of the cone, since we know r, from there we can easily find the value of L. So radius is 3.5, that so r we know. Now to find, we need to find the L, that is the slant height. So L will be square root of r square plus h square. So now let us put the formula over here. So for getting the slant height, let us find the height, that is h first, of the cone. So height is nothing, it is a similar one because the total height is given, and we know that for hemisphere the height is same as the radius. Okay, so if we subtract that from the total height, then we will get the height of the cone. So height of the cone is equal to height of the vessel minus the height of the hemisphere. So height of the vessel is 15.5 centimeter and height of the hemisphere is 3.5 centimeter. So if we subtract, we will get 12 centimeter. That is the height of the cone. Okay. Now, since we know h and we also know r, now we can easily find the L value. That is the slant height. That is equal to square root of r square plus h square. So that is 3.5 centimeter square plus 12 square. So 12.25 plus 144, it is coming 156.25. So h is equal to, if we do the uh, mm, long division, you can here use long division of square root. Okay, then I think you know how to find the long division. So long division of square root, then you can find the value, that is coming 12.5. So 12.5, so L is 12.5 centimeter. So surface area of the cone will be pi r L. So that is pi into 3.5 into 12.5. So that is equal to 43.75 pi centimeter square. So that is the surface area of cone. Now we need to find the surface area, that is the CSA of hemisphere, that is 2 pi r square. So 2 into pi into 3.5 into 3.5. So which is coming 24.5 pi centimeter square. Now what will be the TSA of the toy? That is the CSA of cone and the CSA of hemisphere. So that is S1 plus S2. So S1 already we know 43.75 pi and S2 is 24.5 pi. Now let us add this together. So which is coming 68.25 pi centimeter square. Now replace the value of pi over here. So it is coming 214.25 centimeter square. So this is the TSA of the toy is 214.25 centimeter square. Now we will take a look at the problem based on the cube and hemisphere. Okay, now let's take a look at the problem. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Okay, this is a different type of problem that we have done earlier. Other than that, it's a bit different. So let us take a look at the figure first. So what is from the question, you need to understand how you should draw the figure. So whenever you are solving this surface area volume problem, always try to draw a figure, then only you will be able to understand how to solve this problem. A cubical block of side 7 centimeter is surmounted by a hemisphere. So surmounted by a hemisphere means it should be on top of the block. Okay, so surmounted by means that it is on the top of the hemisphere. Okay, so sorry, it is top on the cube. Okay, the cuboidal block. Now, what is the greatest diameter of the hemisphere can have? So we need to find out the greatest diameter of the hemisphere. So we can clearly see that the greatest diameter is nothing, because we know that in cube all sides are equal. So that is nothing but the side of the cube. Okay, so let us take a look. So the cuboidal block side is given as 7 centimeter. So the greatest diameter of the hemisphere will be the side of the cube because it is on top of the cube, and that is the maximum the hemisphere can have. Okay, so it can be smaller than that. Since it is surmounted by a hemisphere, means that should be on top of the hemisphere. So that is the maximum diameter a hemisphere can have. So the greatest diameter is equal to the side of the square, that is equal to 7 centimeter. Okay, now we need to find the surface area of the solid. Okay, so here the surface area, we need to find the surface area of the solid. So surface area of the solid means the in this cube we have the total surface area, the entire one. Okay, and we need to subtract the base of the hemisphere because whenever we are considering the TSA, that includes the top surface of the cube. But if you take a look, the base of the hemisphere, that is on top of the cube, right? So that is not visible. So whichever portion is not visible, you can't see because that is inside. So we need to subtract that. Okay. So we need to subtract the base of it, and we have to add the curved surface area because that is visible. The curved surface area of the hemisphere, that is visible. So we need to add the curved surface area as well. Okay, so this is the first we need to find the TSA of the cube. Then we need to subtract the base because that is on top of the cube. So it is not visible, the base. And then we need to add the CSA of the hemisphere because that is visible, right? Now let us find one by one. So now first we need to find the formula for finding the TSA of the cube. So that is equal to 6 L square. See, where L is the side of the square, means side of the cube. Okay, so now let us we will just put that formula. Now first we need to find the base, that is the base of the hemisphere. So what is the formula? That is basically nothing but the circle, right? So we need to find this area of the circle. So area of the circle is pi r square. So here r is basically the half of the diameter, and we know that the maximum diameter is 7. So we can easily find the value of r. Now what is the formula to find the curved surface area of the hemisphere? That is equal to 2 pi r square. So if you know the value of r, we can easily find this value of base area and the CSA. Now let us calculate each one. So we know L, we already know, that is 7 centimeter. Now what is R? R is basically the diameter divided by 2. So that is 3.5 centimeter. Okay, so R also we know. Since we know R, so that means we know base area as well as the CSA. Now let us calculate it. So first find the TSA of the cube, that is 6 L square, that is 6 into 7 square, okay, which is 294 centimeter square. Now base area will be, so we need to find the surface area of the solid. So that is equal to TSA minus base area plus the CSA of the hemisphere. So TSA we know 294 minus, now base area is pi r square and CSA is 2 pi r square. So if we do if we simplify it, it is coming 294 plus pi r square. So now 294 plus pi is 22 by 7 into r is 7 by 2. So into 7 by 2. So let us do the division over here. So it is coming 77 by 2. So that is 332.5 centimeter square. So this is the total, that is the surface area of the entire solid, including the cone as well as the hemisphere. Okay. So that is the entire solid surface area. Now let us take a look at some problem based on cube and hemisphere. So the question is, a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Okay, so let us first understand what is given in the question and we have to draw the diagram. So here what information is given, that is a cubical wooden block. So let us draw the cubical wooden block. A hemispherical depression is cut out from one face. So let us consider from the top a hemispherical depression is cut out. So the shape will look something like this, such that the diameter L of the hemisphere is equal to the edge of the cube. So the diameter that is going to be the edge of the cube. Okay. Now determine the surface area of the remaining solid. So whatever is remaining, that we need to find out. Okay. So now first, what is the edge of the cube? So edge of the cube is the diameter of the hemisphere. Let us consider it as L. Okay. Now radius is basically the diameter by 2, that we all know. So that is equal to L by 2. Okay. Now first, whenever we need to find the surface area of the remaining solid means the surface area of the cube minus the surface area of the hemisphere. Okay. So hemispherical, so if we take a look, surface area of the hemispherical, in this case, since they are asking for the surface area, okay, surface area of the solid, so we don't need to consider the curved surface area. So here if we subtract, because if we take a look here, that the surface area also includes the top part, right, top face of the cube, but that part is cut out whenever we are cutting the hemispherical figure. So we need to subtract that area of the hemispherical top. Okay, that is the circular one. Okay, and along with that, we need to also consider the curved surface area of the hemisphere, because that is cut out. So that is going to be the surface area. So the curved surface area of the hemisphere. So this is the surface area of the remaining solid. Okay, now let us calculate one by one. So what is this surface area of cube? That is the TSA, or total surface area of the cube, that is equal to 6L square. Okay, so let us replace that value, 6L square minus hemispherical top is in the figure of circle, so that is pi r square. So pi r square means, that is in terms of, we can write pi r square, and CSA is basically the curved surface area of the hemisphere, that is 2 pi r square. So it is coming 6L square plus pi r square. Now replace this r with L, so L by 2 whole square, so that is equal to 6L square plus pi L square by 4. Now calculate it, simplify it, 24L square plus pi L square by 4. So 1 by 4 L square, if we take common, then 24 by pi. So this is the 1 by 4 L square into 24 plus pi square unit. Since here L is not given, so we can keep it as it is. Okay, as in terms of L and R. So the surface area of the remaining solid will be 1 by 4 L square into 24 plus pi square unit. Since here also the unit is not mentioned, we will just write it as square units. Now we will take a look at the problem based on cylinder and hemisphere. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. So it is a medicine capsule is in the shape of cylinder. So, and cylinder with two hemispheres stuck to of its end. So that means it will look something like this, like a cylinder with each end we have a hemisphere. So the length of the entire capsule is 14 millimeter. Okay. So this is the cylinder and these two are the hemisphere, and entire length is given as 14 millimeter. Okay, and diameter of the capsule is given as 5 millimeter. Okay, find its surface area. So the entire capsule is made up of cylinder and two hemispheres. So the surface area of the capsule will be CSA of the cylinder into plus 2 into curved surface area of the hemisphere. Here we will not consider the TSA of hemisphere. Why? Because the base part, like the circular part, is not visible. That is inside, that is attached with the cylinder. So we will not consider the circular part. We will only consider the curved surface area of the hemisphere over here. Okay, now let us calculate one by one the CSA of the cylinder. So the formula for finding the CSA of the cylinder is 2 pi RH, and CSA of the hemisphere is 2 pi r square. Since we have two CSA, that will be 2 into 2 pi r square. Okay, so now we need to find r and h. So diameter is given, so we can easily find the radius, that is d by 2, that is equal to 5 by 2 millimeter, that is 2.5 millimeter. Now we need to find the height of the cylinder. So we know the total height is given, but here one thing we know, that in hemisphere the radius is same as the height. So that is equal to 2.5 millimeter each. Okay, so the length of the cylinder will be the total height minus the height of one hemisphere minus the height of the other hemisphere. So that is 14 minus 5, that is 9 millimeter. So now we got the length of the cylinder, that is h. So now we know all the values. Let us calculate the TSA of the capsule. So the CSA of the cylinder will be 2 pi RH, that is 2 into pi into r, that is 2.5 into h is 9. Okay, so that is equal to 45 pi millimeter square. Now the CSA of two hemisphere will be 2 into 2 pi r square, that is 4 pi r square. So which is coming 25 pi millimeter square. So the total surface area of the capsule will be CSA plus two hemisphere, the CSA of two hemisphere, that is 45 pi plus 25 pi. Okay, so it is coming 70 pi. Now let us replace the value of pi over here. So which becomes 220 millimeter square. So that is the total surface area of the capsule. So the surface area of the capsule is 220 millimeter square. Now we will take a look at the problem based on cylinder and cone. A tent is in the shape of cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered by canvas, with canvas. Okay, so what is given? The tent is in the shape of cylinder surmounted by a conical top. So that means there is a cylinder which is surmounted by conical top, means the cone will be at the top of the cylinder. Okay, that's what surmounted means, which is on top of it. Surmounted by conical top means it is on the top of the cylinder. If the height and the diameter of the cylinder part are given, so that is 2.1 meter and 4 meter respectively, and also the slant height of the top, that is a conical part, is given. So 2.1 is the height of the cylinder part and diameter is 4 meter. Okay, now so also the top part slant height is given, that is L is given 2.8 meter. Find the area of the canvas. So we need to find the total area of the tent. Okay, so The tent is made up of a cone and a cylinder, that we already know. Okay, so the TSA of the tent will be the CSA of the cone, that is the curved surface area of the cone. Okay, but in this case we will not consider the, I'm telling you, whenever though we are finding here the TSA of the tent, we will not consider the TSA of the cone because the base part is on top of the cylinder, so that is not visible. So we will only consider the curved surface area of the cone. Okay, so this is the CSA of the cone and the CSA of the cylinder. Again, in this case also, we will not consider the base, as it is mentioned already that the base of the tent is not covered with the canvas. So we will not consider the base of the cylinder. So if we just find out the CSA of cone and the CSA of the cylinder, then we can easily find the value of TSA of the tent. So what will be the CSA formula for cone? That is equal to pi RL, and the CSA of cylinder is, we already know that is 2 pi RH. Now we know R and L and H. Okay, so let us put those values. So R is here, diameter is given, so we can easily find the value of R, that is diameter by 2. So that is equal to 2 meter. Then now put the value of R and L and H. Okay, now the CSA of the cone is pi RL, that is pi R is 2 into L is given as 2.8. So that is 5.6 pi meter square. And the CSA of the cylinder is 2 pi RH. 2 into pi into R is 2 meter into H is 2.1. So which is 8.4 pi meter square. So now the TSA will be 5.6 pi plus 8.4 pi. Okay. So that is 14 into pi. So 14 into 22 by 7, which is 44 meter square. So look here, whenever we are solving this type of problem, we are not considering the pi at the beginning. Okay, we are replacing the pi value at the end to minimize our calculation. So this is a way you should minimize your calculation in exam also. So the TSA we already find out. Now the total cost of the canvas of the tent will be the TSA of the tent into the rate, that is 500. So 44 into 500. So let us calculate it. So it is coming, the total cost of the canvas is 22,000 rupees. Okay, so that's all for today's video. Thanks for watching this video. If you like my video, please hit the like button. And if you have any question, you can always put that in the comment section. And please do share this with your friends so that they can also learn before the exam. Like, I would not recommend that you should watch this video before the exam, but if you start watching from now, then it will clear so many concepts and you will also practice the different type of problems. And to get the notification for the upcoming videos, please subscribe to my channel. For that, you just need to press the bell icon. That's all for today. See you in the next video. Thanks. Bye bye.